The thermal cutting methods in use today can be classified into three main groups: flame cutting, plasma cutting, and laser cutting. Flame cutting is still the most commonly used method. In second place comes plasma cutting. Laser cutting is the least extensively used method. This is partly explained by the fact that it's the newest method of the three. The trend for the future is quite clear. The method that's gaining ground most rapidly is laser cutting. The use of plasma cutting is also increasing, mainly at the expense of gas cutting, but also to a certain extent of mechanical cutting. Gas cutting, however, is destined to fall back. In terms of plate thickness, gas cutting has the widest range of application, from 2 millimeters to 2.5 meters. A laser can cut plate all the way down to 0.1 millimeter, and for technical reasons the upper limit is today 8 millimeters. The range covered by plasma is today 1 to 25 millimeters. From an economical point of view, however, laser is the most advantageous method for up to about 4 millimeters and plasma up to about 15 millimeters. The development of new high tensile strength steels entails an increased use of laser and plasma. Which materials are best suited to the different methods? Gas cutting is used exclusively for mild steels, while plasma and laser cutting can be used for all metals. Laser is also used for non-metallic materials. The increased use of stainless steels and aluminium will therefore lead to a wider use of plasma and laser. Common to all three methods is that they all use gas. Several different kinds of gas can be used for plasma cutting. The various plasma methods are named according to the type of gas which is used. The most common plasma types are compressed air, gas, nitrogen with water injection, and oxygen. ABE Bröderna Ekberg manufactures pipe sections in acid-proof stainless steels and titanium. Today, all cutting is performed with air plasma. Earlier, gas plasma was used. The machine zone is equipped with a highly efficient fume extraction system with heavy-duty funnels. The dust particles are separated out with a cyclone and a filter. All of ABE's cutting stations employ air plasma, but a switchover to oxygen plasma is planned for certain units. All plasma-cut surfaces are prepared mechanically prior to welding. With air plasma, you get a high cutting speed and average cut quality. At Sunds Defibrator, all cutting is done with gas plasma. Many of the products are made of special materials such as stainless steel and nickel alloys like Inconel and Monel. This machine features an interesting surveillance system which incorporates a fiber cable, which provides the operator with a unique possibility to monitor the process. The machine can handle plate thicknesses of 4 to 40 millimeters. It uses an L-Tech power source. Plate utilization is today 60%, but with the aid of computerized nesting, this figure can be raised to 80% in the future. This means a payback time for the computers, etc., of only a few months, since the average cost for the material cut in this shop is very high. Since many of the materials are non-magnetic, a suction lift is used in order to avoid expensive surface damage. Gas plasma gives you a low cutting speed, but has the advantage of high cut quality, in particular for the materials in question. Nitrogen with water injection, Volvo BM. Volvo BM uses a machine which incorporates both gas and plasma cutting. This machine can be used with either 6 gas torches or 3 plasma torches. The method used is nitrogen plasma with water injection. The machine is manufactured by Hypertherm. Normally, 3 plates are cut simultaneously. By placing 2 plates lengthwise, however, it's possible to increase machine utilization. Only structural steel is used. All told, a total of 400,000 meters are cut per year using both plasma and flame cutting. the same number of piercings are also performed. AGA traction uses plasma cutting underwater. The cutting equipment is designed for use with nitrogen or water injection. Water injection plasma with nitrogen or oxygen is the best alternative for underwater cutting. With other types of plasma, the reduction in speed is too great. The cutting is carried out about 5 to 10 centimeters below the surface of the water. Among the many advantages of this method are a low noise level, less light intensity, and considerably less dust. This gives an improved working environment in the entire workshop and not only in the operator's immediate vicinity. This is what the cutting operation would look like out of the water. In the early 1980s, AGA Traction began exploring the possibility of robot welding certain parts of our bogey frames. At an early stage, it was clear that robotization would pay off, provided the tolerances of the plate blanks were good enough. Since our blanks lie within 7 and 15 millimeters in thickness, plasma cutting seemed the best alternative. Besides, with plasma it was possible to cut underwater. After having had a look at a number of installations elsewhere in Europe, we understood that underwater plasma was a superior method, both in terms of cut tolerances and the working environment. Nitrogen plasma gives a high cutting speed, while the cut quality is average. Hiab Foco are chiefly engaged in the manufacture of cranes for trucks and boats. The plasma cutting machine they use is fitted with an automatic feed and ejector system for maximum utilization. The material used is primarily high tensile strength steel. The machine performs both punching and plasma cutting. Maximum speed is obtained by punching the start holes and then shape cutting with plasma. Today, cutting is performed with oxygen plasma, whereas earlier air plasma was used. Air plasma prepared joints, however, had a tendency to show signs of porosity in the weld beads. After having switched to oxygen plasma, these defects were eliminated entirely. This is of extreme importance for structures designed to carry a heavy load. Furthermore, the operator's working environment has improved considerably since changing over to oxygen. The downtime for the machine has also decreased significantly. The cuts are free of slag. The cutting range covers plate thicknesses from 4 to 8 millimeters. Hägglunds AB uses oxygen plasma for cutting. The entire plasma cutting station is designed to protect the working environment in the workshop. The operator is normally stationed in an adjacent control room from where he has an excellent view of the cutting table. All loading and unloading of plate takes place outside the cutting room. The cutting table is purpose-designed and provided with wheels. The machine operates with 2 plasma torches on 2 parallel cutting tables. Normally, the material used is either carbon steel or, on occasion, stainless steel. In the summer of 1987, Hägglunds switched over from air plasma to oxygen plasma, which put an end to the problems they had had with inferior cut quality and slag formation. Furthermore, the working environment was improved. We abandoned air plasma because it gave us inferior cuts, which were contaminated because of the presence of nitrogen in the surface of the cut. We had great hopes of getting rid of these problems with oxygen, and I must say that all of our expectations were fulfilled. Furthermore, we got straighter cuts and no slag formation whatsoever. Oxygen plasma is the only type of plasma which gives both a high cutting speed and high cut quality. The commercial plasma types available today are air plasma, which gives a high cutting speed and average cut surface quality; gas plasma, which gives a low cutting speed and high surface quality, particularly with stainless steels and aluminium; nitrogen plasma, which gives a high cutting speed and average cut surface quality. The advantage of water injection plasma with either nitrogen or oxygen is that it allows you to cut underwater at high speed, and that it contributes to an improved working environment. Oxygen plasma, which gives a high cutting speed and high cut surface quality. We note that only oxygen plasma gives you both a high cutting speed and high cut surface quality. Let's review the many advantages of oxygen plasma as compared with air plasma. Increased cutting speed, improved cut surface finish, less angular deviation, no slag, increased plate thickness, and an improved environment. This method not only boosts productivity, it also ensures end products of the very highest quality.